Today, I think it's factoring you've seen before, but I'm going to kind of raise the difficulty level of it. All right. I'm going to go over 3 different methods today. 3. First one's called Gcf, where you can take out something in common. So you see my example up there. I have AB plus 2A. They both have an A in common, so I took out the A and was left with B plus 2. That's called the Gcf method. I'm going to ask, and if you want to make a note of this in your notes, that'd be great. Look for Gcf. Look for a Gcf first. Greatest common factor, if you're wondering what it stands for. Look for a Gcf first. Because if it has a Gcf, you better take it out right away. Okay? If it has a Gcf, you've got to take it out first before going on to any other method. All right, method number 2. 3 terms. If it's got 3 terms, it's referred to as a trinomial. I think you've heard that before, a trinomial. If you have 3 terms, a trinomial, where the number out in front of the squared term is 1, this is what we've been doing all year. Find me 2 numbers that multiply to the n number and add to the middle number, right? We've been doing that all year, test quizzes and homework. So in this problem, problem 2, you guys would find 2 numbers that multiply to 10, but add to 7. Okay, multiply to 10, add to 7. That can only be used if you have a trinomial with a 1 out in front. All right, a trinomial with a 1 out in front. And then this is kind of the new method today. You probably did it last year in Algebra 1, I hope. Difference of 2 perfect squares. Difference of 2 perfect squares. Do you know why it's called difference first? It's got to be subtraction. Okay, it has to be subtraction between the 2. If there's a plus sign in between, no good. It's got to be a subtraction in between the 2. All right, before we move on, let's talk about what perfect squares are. How do you recognize if a number or variable is a perfect square? Have you guys been breaking down radicals all year for me? We got pretty good at it? What was the first step? You needed to find the biggest perfect square that went into the radical. So what are just shoot out numbers that are perfect squares? 25, 16, 9, 4, 9, 16, 25, 36, 49, 64. We could keep going. Those are all perfect squares. So if I see one of those numbers, maybe I have to use this method. What might be tougher for some of you guys is, do you know variables can be perfect squares? Let me show you a couple variables and you tell me what makes it a perfect square. A squared is a perfect square. X to the 4th is a perfect square. C to the 6th is a perfect square. Y to the 18th is a perfect square. What makes a variable a perfect square?
It is double of a normal perfect square?
How do I get 6 then? Right? You guys are taking it too hardcore. It's just that the exponents have to be even. Okay? If the exponent is even, that variable is a perfect square. Okay? Everyone good? So if you see any of these numbers along with any of these variables that have exponents that are even, they're perfect squares. All right? All right, we're ready to buckle up and challenge this and go head on? Here we go, number 1. Factor x squared plus 2x minus 24. Look for a Gcf first, please. Can I take anything out? Anybody take anything out other than the number 1? I don't think you can take anything out of that, right? Okay, what do you notice now? How many terms is it? 3, and what's the number out in front? 1. So now I can play the multiply to the last number, add to the middle number game. All right, I have 3 terms where the leading number is 1. So you can have 2 numbers that multiply to this and add to this. All right, so let me start calling on people, waking people up. 9, 5. Hayden, here you go. I'm looking for 2 numbers that multiply to what? Talking to nobody. All right, let's try it again. Let's try, Will's not here today either. Son of a gun. St. John, here we go. Two numbers that multiply to what?
X plus.
No. I'm just looking. I don't want the answers yet. I'll ask somebody else. I'm looking for two numbers that multiply to what?
24.
Yep, negative 24 and add to what?
2.
2. All right, I need somebody to find those numbers for me. Multiply to negative 24, but adds to 2 at the same time. What are my missing numbers? 21. Zach, what are my missing numbers?
Positive 6 and
Positive 6 minus 4. And I just put the x's with them to finish this. There you go. There's your first factoring. We've been doing that type all year long. Questions from you guys on that part? Because it's going to get a little progressively tougher. All right, what about 2? Ready? Let's go through the process. Any GCF I can take out. Now, how many terms is it? 2. So I can't do the method I just did. But anybody look? Anybody see the number 144? I know we didn't go up that high, but anybody know about 144? It's perfect square of 12. And look at the variables. They both have what as their exponents? Even number, 2. So this is, and finally, what's the symbol inside? In between them, I should say. Minus. So this is what? Difference of two perfect squares. Okay, the difference of two perfect squares. So let's talk right now. When you choose the method, okay, this is difference of two perfect squares. The signs inside the parenthesis are always opposite each other. You don't have to worry about should it be plus, plus, minus, minus. They're always opposite. 144, that was a perfect square for? So 12 and 12. Whatever you put last has to match. And whatever you put in the first two spots have to match. So a squared, b squared. What do you think that's a perfect square for? Divide each exponent by 2. And you end up with AB and AB. Okay? So if you find a variable that's a perfect square, divide their exponent by 2. Everyone all right with this one? Difference of two perfect squares. I decided to hit you up pretty hard first. All right, let's roll. 3. I'm going to be all over you guys about this. What do I want you to look for first? GCF. Plus, you wouldn't have a method anyway because there's a 2 out in front. We don't know how to do that yet until tomorrow. So yeah, there's a GCF. What number can I take out of all 3 terms? What number is divisible by all 3 terms, I should say? Well, what's going on here, huh? I'm so hot. Emily, you got this. What number can I take out?
2.
2, yep. I cannot take out an x because the 18 does not have an x. So just 2. And when you do the GCF method, what you're doing is the 2 that Emily took out, I'm dividing each term by 2. It's division, what you're doing. It's reverse distribution, division. So now you're going to tell me, all right, if I divide every term by 2, what's left? Everyone see we're doing the reverse of what I had you do yesterday. You would end up with this as an answer. What was the question for me to distribute? All right, what's left when I divide everything by 2? It's killing me today. I'm going to snap. I'm going to snap. St. John, going back to you. If I divide everything by 2, what's left?
X squared minus 3x minus 9.
Good job. Minus 3x minus 9. There's GCF. But whoa! This is algebra 2. This is honors algebra 2 now we're doing. So get in the habit of, you take out a GCF, I might not be done factoring. I may still have another factor to go. So look inside, everyone. How many terms do you have inside? 3. What's the number out in front? 1. So can I play the game? Multiply to negative 9, add to negative 3. Can I find those numbers? That's for you to decide right now. Can you find 2 numbers that multiply to negative 9 but add to negative 3 at the same time? Me neither. So we are done. Okay, in this case, this is as far as this can be factored. But hey, you're going to see pretty quickly soon we can go on another step. All right, this is what's so tough about it. Am I done or am I not done? Let's go to 4.
Wait, do we have to take quadratic formula and stuff or no?
Why? Am I asking what x equals?
Oh.
I'm just asking factoring. That's it. I don't need x. I shouldn't see x equals at the end. I'm just asking you to factor. Okay, problem 4. Go through the methods in your mind right now. First method is always GCF. I don't care what the thing looks like. Can I take a GCF out here? Here we go. Omni, can I take something out here?
Yeah, this might be wrong. Can you like divide everything by x?
Okay, x is one thing I can take out, but I also can take out a number.
Oh yeah, you take out 3 as well.
Good. So not only am I going to take out x, I'm going to take out 3x, everybody. All right, I can take, because x is in both of them. I always take out the one with the lowest exponent. Take out the one with the lowest exponent. All right, I take out a 3x. Divide each term by 3x. You guys did this yesterday. Divide each term by 3x. What's left over? What is left over when I divide each term by 3x? Omni, go ahead. Let's finish this.
X minus 4.
Good job. And can I do anything with x minus 4? No. If I don't see a squared, I can't do squat. So there you go. It's just GCF and that's it. Any issues yet? Issues as we start going up the ladder. Anybody at home, any issues? All right, what do you think about 5? Okay, you see 3 terms, but what's the number out in front? 4, so we're definitely not playing the multiply and add game. No way. Not yet, anyway. Again, you know what you got to look for first, every problem. I'm not changing that rule. Look for a GCF first. Maybe. Owen, can I take anything out?
You can take 4 out.
Good job. I'm going to take a 4 out. Divide everything by 4 now. Let's go. Divide everything by 4. What's left?
So many people out.
I have no idea.
Why does the generator only want to think?
Yep. Sophia, what's left inside?
X squared minus 5x plus 6.
Good job. You better take a sneak peek inside. You got 3 terms, leading numbers 1. Can I multiply to 6 and add to -5? I have everyone in class shaking their head yes, so I must think I can. 2 numbers that multiply to 6 but add to -5. What do you got for me? St. John, last one for you today. 2 numbers that multiply to 6 but add to -5.
4x minus 2 and times x minus 3.
Okay, hold on. Okay, yeah, I got you.
We got the
I got you. X minus 2, x minus 3. I just made a common student mistake. X minus 2 times x minus 3, if I asked you guys to double distribute, will not get what we started with. Why not, Emily? Yeah, you have to keep bringing down the GCF into your final answer. All right, a lot of people commonly forget that. Here is my final answer, GCF and all. Questions? How are we feeling here? And this is the easy part of factoring, believe it or not. How about 6? What are you thinking about 6? You got 3 methods today. Is there a GCF? Okay. If there's not, is it 3 terms, perfect squares? Where am I working here? I got 100 and x squared. Talk to me. And we get another one. Emily, Sammy,
What?
what do you think for this one?
The difference of.
Good. Difference of 2 perfect squares. Emily sees 100, and she sees x squared, which are both perfect squares. All right, so I set up my parentheses. I threw a little wrinkle in this one. Plus, minus, or reverse them, I don't care. Everyone see how it's a little backwards? Usually the numbers last and the variables first. Well, you have to write it like that, though. You have to write it backwards. So 100's a perfect square for 25.
Oh my god. Sorry.
Okay. 10.
Sorry.
I think that's what you meant. So the 10s have to go first because the 100 was first. And then x squared is a perfect square for x. Okay? If you guys wrote it like this, x plus 10, x minus 10, that's incorrect. Here's why. What's x times x? And what's it in the problem? Negative x squared. So that's why you can't write it x plus 10, x minus 10. It's got to be written backwards, just like that was. Okay? Oh boy, I love number 7. 7. Only superstars need to apply to number 7. Oh boy. I'll let you take a look at it first. A lot of students just start foaming at the mouth because they see something, but you got to wait to foam at the mouth. All right. What do you see on number 7? Sophia, what do you see on number 7?
You do have 2 perfect squares with 36 and 100.
You do, and you c squared and d squared, right?
Yeah.
And that, that's what a lot of students see right away, and they go difference of 2 perfect squares. Unfortunately, though, what do you always go through first? GCF, and this has a GCF in it. Yes, I know 2 works, but there's GCF is greatest common factor, not the first one you find. And the highest number, Sean?
4.
Should be 4, yes. And I'll show you why. Let me do this problem all out, and I'll show you why difference of 2 perfect squares wouldn't be okay at the beginning. So let's take a 4 out. Hopefully you guys got your calculators if you need them nearby. If I take a 4 out, what's left? Emma, what's left?
9c squared minus 20d squared.
20?
5, sorry.
25d squared. Good. And now you can foam at the mouth. Why? Look inside now. What do you see? Difference of 2 perfect squares. 9 and 25. C squared and D squared. All perfect squares. Yep. Now, bring down the 4. And now I can apply difference of 2 perfect squares. Who's applying the perfect squares here? Sean, go ahead.
4, 3c minus 5d, and then 3c plus 5.
Yep. 3c, 3c, and then 5c, 5d, 5d. There it is. Okay, everyone, please stop and just focus here. I want to show you. Remember, Sophia said at the beginning, she's like, hey, difference of 2 perfect squares, and she was correct. So let's say we factored it using difference of 2 perfect squares. What's the perfect square for 36? So it would be 6c minus, what's 100 perfect square for? 10d. And then I would do the opposite, 6c plus 10d. Anybody know why I couldn't accept that as a final answer? Quincy?
It's you can divide both like him.
There's still a number I could take out of both. So it's not factored all the way yet. What can you take out from 6 and 10?
2.
A 2 here and another 2 here. See where I get 4? Okay. So that's why if you left it 6c minus 10, 6c plus 10, I couldn't leave it like that.
Wait, so if you forget to take the GCF out and then you realize at the end?
You could. It's still doable. Ridiculous. Yeah, you see what I did there? I took a 2 out and a 2 out, which gives me 4. And then I guarantee you would be left with 3c minus 5d times 3c plus 5d.
You multiply them, right? Yeah.
Yep. And then I multiply the 2's, and that's where the 4 comes from. So we could get away with it. I just don't know how many people would see that right off the bat. Always look for a GCF first. Number 8. Go ahead, number 8. Look for a GCF first. Maybe, maybe not. I don't think 3 is a perfect square, or y to the third is, so that's going to be a tough method to use. All right, what do you want to do to number 8 first? St. John's good for the day. How about one below? Ryan, there we go. What do you want to do with 8, Ryan?
Take out 3y.
Darn right. I could take out a 3, and I could take out a y. All right, divide everything by 3y. Let me know what you get inside. Divide everything by 3y. What do you get inside using GCF? Ryan, keep going. Your problem, I guess.
It'd be y squared minus 64.
Ooh, 64, he says. 64. All right, this is where the honors comes in, this part. Don't box it in, right? Be more disciplined. Do not box it in. Y squared minus 64. What do you want to do there? I can keep going. Ellie, what can I do with y squared minus 64?
It's a perfect square.
Yep. So here we go. Y plus what and y minus what, Ellie? What's 64 a perfect square for?
8.
Yep.
So it'd be y plus 8 and y minus 8.
There you go. And then I just got to make sure, everyone, bring down your GCF of 3y to finish the problem off. We are just factoring machines right now. Anything I can answer going? Ooh, how do we feel? Can I take a temperature gauge here other than the heat? We okay? People at home, we all right? I just get nervous because I know what's coming too. And it's not any easier than what we're doing now. All right. 9. Factor that beast. Why not? Omni, last one for you. What do you want to do with 9?
I want to take out a GCF of 2x.
Yes, indeed. Nice job. Excellent. So I'm going to take out 2x. I put this problem in specifically for what you're going to leave inside the parentheses or not. I'm going to see if somebody leaves something out or not. Remember, when you take a GCF out, you are dividing each term by it. Remember that. All right, what's left inside then? Let's see if somebody can get it.
It's like they don't know the other people in the 26 is
Maeve!
Yay.
There we go. What's left?
X squared plus 3x plus 1.
There it is. There it is. There's what I want to make sure. Everyone, make sure you got the plus 1 in there, right? Because when you divide 2x by the GCF of 2x, it's not equal to 0. It's equal to 1. Good. I'm left with a 1. Maybe. Maybe. Keep going. Maybe. I got 3 terms. Multiply to 1, add to 3. Anybody want to take it? Multiply to 1, add to 3. Going? Good. Don't be an embarrassment. You're done. There's no numbers that multiply to 1 and add to 3. Right, Zach? Darn right. 10. Let's go. Radika escaping today, huh?
I don't really get called on much. Like the generator doesn't teach me very often.
It doesn't recognize. Okay. What do you want me to do for 10? Quincy, what do you want me to do for 10?
Factor out for AB.
Good. I can take out a 4. I could take out an A and a B because they both have A and B in them. Perfect. All right, what are we going to do with what's left? Divide everything by 4AB. What's inside? There he is, Luke. What's left?
AB.
Oh, hold on.
Oh, wait.
I'm taking a 4, an A, and a B away from 4AB squared. What's the only thing left? Just B, yep, minus?
Minus 3A. Yeah.
And then you're going to be quiet, right? Thank you. There it is. Whew. All right, so GCF method. Difference of 2 perfect squares. And multiply to the last term, add to the middle one. tomorrow, I think you've been exposed to it in Algebra 1, the grouping method will be discussed. Okay, grouping method. What happens if I actually have a number other than 1 in front of a trinomial? All right, so you guys in class can get going on the worksheet. You guys at home, you don't need to stay, but make sure that worksheet gets done. Be smart, be safe. See everyone tomorrow.